I'm going to look at this question in this video and I'm going to take my time to explain the environment of the question. One thing in physics is that you need to first of all start by understanding the nature and the environment in which the question was taken. And that will give you a better understanding, a clue of what the examiner wants you to do in this question. And here there's a wall here. Of course, we use this to represent a vertical wall, that line there, and one end of a spiral spring. Spring has a good spring constant, and attached to it. The other end is fixed to a block P. You can see the block P, and this block P lies on a smooth horizontal surface, meaning that we're going to neglect the effect of frictional force. And then at the first, the position of block P was here. Let me call this point A. Point A was the original position of block P, and by way of applying some force, this block P, the force now compresses the spring such that block P moves from where it was before initially at point A to this new point B. Okay, I hope you are getting that. And by way of moving this block P from this initial position of A to B, that block P has compressed the spring by this same distance, 5 centimeters. You can see that the two positions are 5 centimeters apart. Okay, so that becomes the compression that is produced in this spring. And from Hooke's law states that the force applied to a spring to an extensible elastic material is directly proportional to the extension or compression produced in the material. So we are going to use the ideas of the formation of solids, that is, elastic properties of solid, to also solve this problem. And here we are told that by so doing, the mass of the block P is 1.5 kg. Of course, you can see that now the distance compressed is 5 cm, and then the force applied produces an energy of 10 joules. The energy that is transferred into the compressed spring. Recall that when an elastic material like a spring is extended, stretched, or compressed, it stores energy. The work done in compressing that spring becomes the energy stored in that spring. So by the way of applying some force F here to move this block from this point to this point, that work done has transferred some energy into the spring, and that energy is called the elastic potential energy stored in the spring. Okay, so the block is released after some time, and then what happens? It moves backward because the energy that was transferred to this spring will have to do some work on the block when once the block is released at this point, and that is to push this block past the original position until it collides inelastically. You can see that now it collides inelastically with a stationary block Q of mass 3.5 kilogram. That is the mass of this block Q. And after the collision, of course, you know that since it's inelastic, some form of energy is lost, like kinetic energy is not usually conserved in an inelastic collision. So we have to here find the value of force K and then the force constant, of course, also the acceleration of the block and also the common speed after the collision of the two blocks. How do you attempt this question? Maybe I'm going to look at this. Look at the different board we placed in front of the question to solve for the first one, which is the value of force K. And from Hooke's law, force F is equal to K times E. And then the force applied is not given. But you know that the energy that is stored in the compressed spring is half K times extension squared. Okay, for those that have already gone through this topic, you know what I mean. If you have not already done this topic, then you have to go quickly and read up Hooke's law, extension, and elastic properties of material. So since the energy was given 12 joules, so I put here 10, or sorry, I put here 12 joules is equal to half times K, which is what I'm looking for, multiplied by the extension. Here it is compression. It is compressed by 5 cm. So my compression is 0.05 meters. I have to work with standard unit. That gives me 0.05 squared. So if I cross multiply, I have 24 is equal to 0.05 squared times K. And then dividing both sides by that, I have K is equal to 24 divided by 0.05 squared. Okay, so let me bring it into the picture so that I don't go past my people here. Okay, so I have the spring constant as 9,600 Newton per meter. Okay, so that is the spring constant of this very spring. So the next question I'm to find the force that is used to compress the block, and that force from Hooke's law F is equal to a spring constant times extension. So my spring constant, I've got it as 9,600 multiplied by 0.05. Okay, when I multiply this by 0.05, the force F is 480 newtons. So that was the force that was applied to compress the spring. Okay. Now the next question says the acceleration of the block P. Newton's second law of motion, resultant force on the block is mass times acceleration. And here you can see that block P lies on a very smooth horizontal surface. Very smooth horizontal surface, so which means there's no frictional force acting between the two surfaces. So I'll come here to find the acceleration. I know the mass. The mass of block P was given as 1.5 kg. Okay, so the acceleration is force over mass. That gives me 480 divided by 1.8. Okay, so what is 480 by 1.8? By 1.5. So 480 by 1.5, that gives me 320 meters per second squared. Oh, that's a very large acceleration. And the speed will increase terribly. So for the last question, I want to find the common speed after the impact. That is the last question here, to find the common speed. To do that, we need to find the initial speed of block P. Block P moves this way after it is released towards, let's call that U1, with initial speed U1 towards block Q in order to collide with it. Okay, so we need to find that from one of the equations of motion. So let's say that block P was released from rest. Its initial velocity is 0. Okay, so its acceleration is given. We already calculated that at 320 meters per second. Alright. Now, for one of the equations of motion, since it takes 0.2 seconds before it collided with block Q, you can see it is shown there that it takes 0.2 seconds to collide, so that's the time. I have my V from equation 1, U plus 80, that gives me V, which is what I'm looking for, equals to 0 plus 0.2 times 320, okay? That gives me 64 meters per second. We multiply that. So this gives the initial speed of P. That's called a U1. So that 64 is the initial velocity of P before it's head-on collision with Q. Okay, so I'm going to keep that. Then that of Q was at rest initially, so I give that 0. And then we have the mass of this block P, 1.5 kg. Mass of the other one is 3.5 kg. So I have to use the Newton conservation equation here. M1U1 plus M2U2 equals M1V1 plus M2V2. So this is 0 because it was pressed initially. That gives 1.5 times, I got the speed at 64 is equal to 1.5 plus this is 3.5 because I'm going to factor this V1 equals V2 equals V, which is the common speed of velocity. So that gives me times V, the common speed. So I have 1.6 times 6.4, that gives me 96 is equal to 5V. So the common speed is 96 over 5, which gives me 96 divided by 5. My answer is 19.2 meters per second. So both of them move at the common speed of this meters per second.